Alright, today we're covering 4 things every security professional needs to know cold: the Windows Registry, Windows Services, the basics of Active Directory, and PowerShell. These aren't 4 random topics thrown together. They're how Windows organizes itself internally and how it gets managed across an entire network. And here's why you should actually lock them in now rather than skim past them. They resurface constantly later in this course. The registry comes back in Module 12, when we cover persistence. Services come back in Module 11, privilege escalation. PowerShell shows up constantly in Module 17, threat hunting. Get these 4 right now, and a lot of harder material gets easier later. So by the end of this video, you'll be able to explain what the registry actually is, how it's organized, and why both attackers and defenders care about it. You'll know what a Windows service is, how it's different from a normal application, and exactly where it creates risk. You'll understand the Active Directory hierarchy, forest, domain, organizational unit, objects, and how AD proves who you are. And you'll understand why PowerShell works fundamentally differently from a normal command shell, and how it gets used on both sides of the fence, attack and defense. One more thing before we start. Near the end of this video, I'm going to run through a set of test-yourself questions pulled straight from this module. When we get there, actually pause and try to answer before I give you the answer. Getting one wrong, and then checking, cements it far better than just listening straight through. That's the whole point of including it. Let's start at the top, the Windows Registry. Let's start with the registry, because honestly, very little else in Windows administration fully makes sense until this one clicks. The registry is a single, hierarchical database. That's the technical definition. Here's the plain version. It's where Windows stores nearly every low-level setting about itself and about any application that chooses to use it. Hardware configuration, driver settings, installed software preferences, user profile settings, security policy. If it's a setting that needs to survive a restart, and it isn't one of the actual files you created yourself, it almost certainly lives in the registry. Think of it as the settings and the DNA of the machine combined into one structure. It wasn't always this tidy, by the way. Early versions of Windows let every application keep its own separate .ini text file, scattered across the disk, with no consistent structure and no central place to look anything up. The registry replaced that mess with one searchable, permission-controlled, hierarchical store. At the very top of that structure sit 5 root containers, called hives. Every setting on the machine lives under one of these 5, so let's go through all of them by name. HKLM, the local machine hive. This holds machine-wide settings, installed software, hardware, drivers, services, anything that applies to every user of that PC. If a building has shared infrastructure, the lifts, the boiler room, the wiring, HKLM is that. HKCU, the current user hive. Settings for whoever is logged in right now, wallpaper, mapped drives, recent files, personal app preferences. If HKLM is the building's shared infrastructure, HKCU is your own flat inside it. HKU, the user's hive. The same kind of per-user data as HKCU, except it holds it for every user profile on the machine at once, every flat in the building, not just yours. HKCR, the class's root hive. This governs file type associations, which program opens a .docx file, for instance. Think of it as the building's directory board in the lobby. And HKCC, the current config hive. Just the hardware profile currently in use. Today's floor plan. Here's a detail worth knowing cold, especially if you ever move into forensics. Only 2 of those 5 hives are actually physically stored on disk as independent structures, HKLM and HKU. HKCU is really just a shortcut pointing into HKU, at the spot matching your account's unique security identifier. HKCR is a merged view, built from 2 different software/classes locations, one from HKLM, one from HKCU. And HKCC just points into a specific spot inside HKLM. 5 hives to think about conceptually, but only 2 physically separate stores underneath them. Below each hive, the structure works almost exactly like a folder tree. A key works like a folder. It can hold more folders, called subkeys, or it can hold actual data. A value is that actual data entry stored inside a key, and every value has 3 parts: a name, a type, and the data itself. That type matters more than it sounds like it should. The most common one is regSed, registry speak for a single text string, something like C:\program files \app\app.exe. regExpanderSed is a string containing an environment variable to be expanded, like %systemroot %\system32. regdword is a 32-bit number, very often used as a simple on or off switch. regbinary is raw binary data. And regmultised stores a list of several text strings at once. So why does any of this matter if you're heading into security rather than IT support? 3 reasons. 1. Persistence. 2 keys in particular, HKLM/software/Microsoft/Windows/current version/run, and the matching key under HKSU, tell Windows to launch a program automatically at every login. Perfectly legitimate software uses these constantly, antivirus, cloud sync clients. So does malware, because it's a simple, reliable way to survive a reboot. 2. Security configuration lives here too. User account control behavior, Windows Defender settings, and a lot of group policy results all get written into the registry eventually, which is exactly why Harden the registry shows up in so many security baselines. And 3. It's a forensic goldmine. Recently opened files, plugged in USB device history, installed program lists, even typed search terms, all recoverable from the registry long after the fact. That becomes core material later, in the digital forensics content of Module 15. 4 tools, regedit.exe is the GUI, browse and edit the registry visually, and it's what you'll open for this module's exercise. regExe is the command line version, query, add, or export registry data from a script or terminal. And in PowerShell, the registry is exposed as a navigable drive. You can cd straight into HKLM:, and use getItem property on it exactly like you would with files. Here's your hands-on step. Open regedit, Windows key, type regedit, press enter. Without changing anything, browse to 3 locations. First, HKLM/software/Microsoft/Windows/current version/run, see what launches automatically on your machine. Second, HKCU/control panel/desktop, find the wallpaper path setting. Third, HKLM/software/Microsoft/Windows/NT/current version, check the exact build number installed. Look only, for now, editing the wrong key can stop Windows from booting, so treat regedit as read-only until you've had dedicated practice with backups. So, to bring the registry together, it's one hierarchical settings database, split into 5 hives, only 2 of which are truly separate on disk. Keys work like folders. Values are the name, type, and data settings sitting inside them. And it matters to security because it's a favorite persistence mechanism, a store of security-relevant configuration, and a rich source of forensic evidence. Now to something that's running on your machine right now, whether you're logged in or not, Windows services. A Windows service is a program built to run in the background, with no user interface, completely independent of whether anyone is even logged in. Most services start automatically the moment the machine boots, before any user has even entered a password, and they keep running the entire time the machine is powered on. Compare that to a normal application, like a web browser. A browser only exists while a specific user has it open, and it disappears the second that user logs off. A service is nothing like that. It behaves more like the permanent kitchen and maintenance staff of a large hotel, working around the clock whether or not any guest is currently checked in, quietly keeping the building itself running. Windows genuinely depends on dozens of these for basic functionality: networking, print spooling, Windows Update, DNS resolution, time synchronization, and plenty more. Every one of those services, how it starts, stops, and gets supervised, runs through one central component, the Service Control Manager, or SCM, which itself runs as a process called services.exe. So whenever you start, stop, or restart a service, whether by clicking a button in a console or typing a command, what you're actually doing is asking the SCM to do it on your behalf. Every service has 4 attributes worth knowing. Its service name is the internal short identifier Windows uses, something like DNSCAKE for the DNS client. Its startup type controls when, or whether, it starts automatic, automatic delayed, manual, or disabled. Log on as is the account identity the service runs under: local system, local service, network service, or a custom account. And its state is simply what it's doing right now: running, stopped, paused, starting, or stopping. That third attribute, log on as, matters far more than it sounds like it should. Local system is the single most powerful account on the entire machine, in some respects broader than even a local administrator account. Which means a service running as local system that a lower privileged user can somehow manipulate becomes a direct path to full control of that machine. Which leads straight into why security people care about services at all. 3 reasons. First, high privilege, high value. Many services run as local system. If an attacker can get a service to run code on their behalf, say, by replacing a file that service loads or exploiting a permissions mistake, they inherit that service's privilege level instantly. Second, unquoted service paths. This one's subtle, so stay with it. If a service's executable path contains spaces, and that path isn't wrapped in quotation marks, Windows will actually try several shorter interpretations of that path before it lands on the correct one. So if an attacker can plant a file at one of those earlier, incorrect locations, Windows runs the attacker's file instead, with whatever privilege level that service had. You'll cover exploiting this class of bug hands-on in Module 11. For now, the habit to build is simple. Every service and shortcut path that contains a space should be quoted, full stop. Third, persistence and camouflage. Installing malware as a service is a well-known way to survive a reboot, and it blends in among the dozens of legitimate services already running on any given machine. It's also exactly why security software itself, your antivirus, your EDR agent, typically runs as a set of protected services too. 4 tools. Services MSC opens the Services console, a GUI where you can browse, start, stop, and configure services visually. SEXE is the command line equivalent, SC query, SC config, run from a terminal or a script. And in PowerShell you've got get service, start service, stop service, and set service, the fully object-based version of the same thing. Try this yourself. Open the Services console, Windows key, type services MSC, press enter. Find and note the startup type and the log on as account for 3 well-known services: Print Spooler, internally called Spooler, Windows Update, internally called Warzov, and DNS Client, internally called Dienstcake. Notice how their startup types differ from each other, and think about why something like DNS Client genuinely needs to already be running before you've even opened a single application. To sum up services, they run in the background, independent of any logged-in user, all managed centrally by the Service Control Manager. Each one has a startup type, a logon account, and a current state. And because so many run with high privilege, misconfigured services, especially unquoted paths and weak permissions, are a classic route to privilege escalation. They are just as popular as a persistence mechanism for malware. Topic 3. Active Directory, often just shortened to AD. If you remember only one phrase from this whole section, security people call it the keys to the kingdom, and by the end of this part, you'll understand exactly why. Active Directory is Microsoft's directory service, a centralized database, plus a set of services, for managing every user, computer, group, and permission across an entire network from one place, instead of configuring every machine individually. Here's a picture that makes it click. Imagine a school with no central administration at all. Every classroom keeps its own separate roll call of who's allowed inside, makes up its own rules, and keeps its own private record of which club each person belongs to. That works fine for one room. It falls apart completely past a handful of rooms. Active Directory is that school's central admin office, one authoritative roster covering every student and staff member, which in computer terms are your users, every classroom, your computers, every club, your groups, and every rule each group has to follow, your group policy. And critically, every classroom in the building simply trusts whatever the central office says. AD organizes all of that into a nested hierarchy. Picture 4 boxes, each one sitting inside the last, largest to smallest. The outermost box, the biggest one, is the forest, the outermost security boundary, a set of domains that all trust each other and share one common schema. Sitting inside the forest is the domain, a distinct security and administrative boundary with its own database. Something like corp.example.com would be one domain. Inside a domain sits the organizational unit, or OU, a container used to group objects together so you can apply policy to all of them at once. And inside an OU sit the actual objects themselves, users, computers, groups, and group policy objects, or GPOs. So, top to bottom, forest, containing domains, containing organizational units, containing objects. If you ever hear the term tree, that's simply a set of domains inside the same forest that share a continuous DNS namespace. Corp.example.com and a child domain like sales.corp.example.com would form one tree together. A single forest can contain several trees. It's more of a naming detail than a concept worth losing sleep over at this stage. Within that structure, there are 4 key object types to know. A user is a person, or sometimes a service account, that can log in and authenticate. A computer is a machine that's joined the domain and can be centrally managed. A group is a named collection of users or computers, letting an administrator assign permissions once instead of person by person. And a GPO, a group policy object, is a bundled set of configuration settings applied automatically to whatever organizational unit it's linked to. All of that data physically lives on a server called the Domain Controller, or DC. The Domain Controller holds the actual AD database, a file called ntds.dit, and it's the machine that answers authentication requests. Here's the key mental model. When you log into a domain-joined machine, that machine isn't checking its own local list of accounts. It's asking a domain controller, is this really this person, and what are they allowed to do? So how does that authentication actually happen? Modern AD authenticates primarily using Kerberos, a ticket-based protocol. In simplified terms, when you log in, a domain controller, acting as what's called a key distribution center, issues you an encrypted ticket proving who you are, without ever sending your password across the network again for every new resource you access. From then on, you present that ticket, not your password, whenever you need to prove your identity to another server. NTLM is the older challenge response protocol AD used before Kerberos came along, and it's still present today purely for backward compatibility, older systems, and workgroup, meaning non-domain, authentication. Both of these matter well beyond this module. Kerberos ticket abuse, called Kerberosting, and NTLM hash abuse, called pass the hash, are both named specifically in your Module 11 syllabus. Right now, the goal is just recognizing that these two protocols exist, and roughly what they are. How they actually get attacked comes later, once you've had the legal and ethical framing at the top of Phase 3. One more protocol to keep separate in your head, LDAP, the Lightweight Directory Access Protocol. This is the actual protocol client software uses to read and query the AD database. Think find me every user in this OU. Here's the clean distinction. LDAP is how you talk to AD. Kerberos and NTLM are how you prove who you are to it. Beyond authentication, AD also supports trust relationships. These let users in one domain, or even one forest, access resources in a completely different domain or forest, without needing a totally separate account. Trusts can run one way or two-way, and they can connect domains within the same forest, or bridge entirely separate forests. Large organizations that have merged with, or acquired, other companies often end up managing a whole tangled web of these trusts. And this is exactly why Active Directory earns that nickname, the keys to the kingdom. In most organizations, compromising AD, specifically obtaining domain admin rights, is functionally equivalent to compromising every single domain-joined machine on that network all at once. That's precisely why AD authentication is such a heavily targeted area in real-world attacks, and why so much of both the offensive content in Phase 3 and the defensive, threat-hunting content in Phase 4 of your curriculum keeps circling back to it. Tool-wise, AD Users and Computers, or DSMSC, is the GUI for browsing and managing users, groups, computers, and OS visually. The AD module for PowerShell gives you Get AD User, Get AD Group, Get AD Computer, and dozens more, the modern, scriptable way to query and automate AD at scale. And ADSI Edit is the advanced GUI for low-level, direct editing of AD objects and their attributes. Bottom line on Active Directory, It centralizes identity and access management for a whole network. Its hierarchy runs forest, then domain, then organizational unit, then objects, users, computers, groups, and GPOs. Authentication happens primarily through Kerberos, with NTLM hanging around as a legacy fallback, and LDAP is the query protocol underneath all of it. Because compromising AD generally means compromising the whole network, it's one of the single highest value targets in enterprise security. Last of the 4 core topics, PowerShell, and this is the one that changes how you think about a Windows shell entirely once it clicks. PowerShell is Microsoft's modern command line shell and scripting language, built on top of the .NET framework. It ships with every current version of Windows, and, since PowerShell 7, which used to be called PowerShell Core, it also runs natively on Linux and macOS. It's built for exactly the kind of work a security professional or system administrator does constantly, automating repetitive tasks, managing configuration at scale, and pulling structured information out of the operating system fast. Here's the single most important idea in this whole section, so let it land. PowerShell passes full objects between commands, not plain text. That's the one thing that separates it from Bash, from CMDXE, from basically any traditional shell you've used. Think about how this normally works. In a traditional shell, finding the process using the most CPU typically means running a command, getting back a block of formatted text, and then piping that text into other tools, grep, awk, sed, just to cut out the one column you actually need. If that text formatting ever changes even slightly, your parsing breaks. In PowerShell, that same process list isn't text at all, it's a collection of real objects, each one still carrying its named properties, name, CPU, ID, and so on. You don't parse anything to get the CPU column. You ask for the CPU property directly, and what comes back is still an actual number, not a string of text you have to reinterpret. Here's an analogy that makes it stick. A traditional shell's pipeline is like handwriting notes on paper and passing them to a colleague, who then has to squint at your handwriting to find the one number they need. PowerShell's pipeline is like passing along a filled-in spreadsheet row instead. Your colleague just reads the CPU cell directly, because it was always a distinct, labeled field. Never a blob of text to decode. PowerShell commands are called commandlets, and every one follows one predictable pattern, verb, then noun. Once that pattern clicks, you can often guess the correct commandlet name on your very first try. Get retrieves information, get process, get service. Set changes a setting, set item property, set service. New creates something, new item, new aid user. Remove delete something, remove item, remove service. Start or stop begins or ends something running, start service, stop process. The pipe symbol connects all of this. It passes the output objects of one commandlet directly into the next as input, exactly as just described, except now real objects are flowing through, not text. A simple example, get process, piped into sort object CPU, with the descending flag. That single line retrieves every running process, then sorts those actual process objects by their CPU property, highest first, with zero text parsing anywhere in that sentence. One of PowerShell's more elegant tricks is the provider system. It lets you navigate things that aren't actually files or folders at all, as if they were a file system, and this connects straight back to 2 things already covered. Type cd, space, hklm:/, and you can browse the registry from part 1 exactly like a set of folders, because to PowerShell, at that moment, it genuinely is one. And with the AD module loaded, cd ad:/ lets you browse Active Directory from part 3 the exact same way. Same navigation commands, cd, dir, or getChildItem, pointed at 2 completely different underlying systems. Scripts don't run in PowerShell unrestricted by default, either. A setting called execution policy controls that, and there are 5 levels. Restricted means no scripts run at all. All signed means every script, including your own, needs a trusted digital signature. Remote signed means locally created scripts run freely, but anything downloaded from the internet must be signed. Unrestricted means all scripts run, with just a warning for internet-sourced ones. And bypass means nothing is blocked, and nothing warns you at all. Here's the nuance worth internalizing early. Execution policy is a safety rail against accidentally running a script. it is not a real security boundary. It's trivially bypassed by anyone with a little know-how. Don't rely on it as an actual security control. It exists to stop honest mistakes. It does nothing to stop a determined attacker. Which brings us to why security professionals care about PowerShell specifically, and it genuinely cuts both ways. For defenders, it's an automation powerhouse, parsing logs, deploying hardening settings, pulling forensic artifacts, and querying dozens of machines at once. Much of the SOC tooling in Module 14, and the forensics work in Module 15, leans on exactly this. For attackers, it's just as attractive, for a different set of reasons. It's already installed and trusted on virtually every Windows machine, it can execute code entirely in memory without ever writing a file to disk, and it can blend malicious activity in with completely normal admin traffic. That whole technique category has a name, living off the land, named directly in Modules 12 and 26. Because of all that, PowerShell logging, specifically script block logging and module logging, has become one of the single highest value data sources in modern threat hunting. It's called out by name in your Module 17 syllabus. For tools, Windows Terminal, PowerShell.exe, or PWSH is where you'll actually run commands day to day. PowerShell ISE is the older, built-in script editor, and it's being phased out. VS Code with the PowerShell extension is the modern standard for writing anything longer than a one-liner. To wrap up PowerShell, it's a shell and scripting language that passes structured objects, not text, through its pipeline. That's the single biggest reason it behaves so differently from Bash or CMD. Let's follow that predictable verb-noun pattern. Providers let it browse things like the registry or Active Directory as if they were folders. And execution policy is a safety rail, not a security wall. Its power, and the fact that it's everywhere, makes it equally central to defensive automation and to real-world attacker tradecraft, exactly why PowerShell logging is such a prized detection source. Now that we've gone through all four pieces individually, let's zoom back out, because these aren't four unrelated trivia lists. They're one connected system, and that's exactly why Module 2 groups them together in the first place. Here's how they link up. PowerShell can read and write the registry directly, using it as just another drive to browse. That's PowerShell reaching into the registry. The registry stores the exact configuration, startup type, logon account, that defines how every service behaves. That's the registry feeding directly into services. Services are frequently what's actually running the software that authenticates users against Active Directory. And Active Directory determines who's allowed to log in at all in the first place. The moment someone does, it's their own personal registry hive, HKSU, that gets loaded. So Active Directory loops right back around into the registry. And PowerShell, once again, is very often the actual tool used to query, configure, or automate all three of those systems, including Active Directory, through its own dedicated module. Picture that as one chain, top to bottom. At the top, Active Directory, it decides who can log in the first place. One level down, the registry, it loads that user's HKCU profile and configuration. Below that, services, they keep the machine's background functions running. And at the bottom, PowerShell, which can inspect, automate, or manipulate any part of everything above it. And here's why this is worth holding on to, not just for this module's quiz, but for the rest of the course. These four topics resurface constantly later on. The registry comes back in Module 12, for persistence, and Module 15, for digital forensics. Services come back in Module 11, for privilege escalation, and again in Module 12, for persistence. Active Directory comes back in Module 5, for Identity and Access Management, Module 11, for Kerberoasting and Pass the Hash, and Module 21, for Azure AD. And PowerShell comes back in Module 12, for Living Off the Land Techniques, Module 17, for Threat Hunting and Logging, and Module 26, on Advanced Persistent Threats. Lock in these four systems now, how they work individually, and how they connect to each other, and you're not just passing this module. You're preloading context you'll need in at least 7 modules down the line. Before we test what actually stuck, here's the entire module distilled onto a single page, and this is genuinely worth pausing on, because you'll want it open next to you during the hands-on lab. Registry, 5 hives, then keys, then values made of name, type, and data. Primary tools, regedit.exe, regd.exe, and PowerShell through HKLM:. One thing to remember, only HKLM and HKU are truly separate on disk. Services, managed by the SCM, defined by a startup type, a logon account, and a state. Primary tools, services.sc, sexe, and get service. One thing to remember, unquoted paths with spaces are a classic escalation route. Active Directory, forest, then domain, then organizational unit, then objects. Primary tools, DSAMSC, ADSI edit, and the AD PowerShell module. One thing to remember, Kerberos, using tickets, is the primary authentication method, NTLM is only the legacy fallback. PowerShell, commandlets follow the verb-noun pattern, and they pipe full objects. Primary tools, PowerShell.exe, PWSH, and VS Code. One thing to remember, objects flow through the pipeline, never plain text. That's the whole module, in 4 rows. Alright, time to actually test what stuck. I'm going to run through 13 questions pulled straight from this module. For each one, hit pause and genuinely try to answer it yourself, out loud or in your head, before I give you the answer. This is honestly the most useful part of this whole video, if you actually do it instead of letting it play through. Let's start with the registry. Question 1. Which registry hive would you check to find settings that apply only to the person currently logged in, not the whole machine? Here's the answer, HKCU, the current user hive. Question 2. True or false? The class's root hive is stored independently on disk as its own separate hive? Here's the answer, false. It's a merged view of HKLM/software/classes and HKCU/software/classes. It isn't an independently stored hive. Question 3. Name the 2 data parts, besides the name, that every registry value contains. Answer, type, and data. Now, services. Question 4. What is the Service Control Manager, and what does it actually do? Answer, the SCM, running as services.exe, is the central component that starts, stops, and supervises every Windows service. Question 5. List the 4 possible startup types for a Windows service. Answer, automatic, automatic delayed start, manual, and disabled. Question 6. Why is a service configured to log on as local system considered higher risk, if it can be manipulated? Answer, because local system is the most privileged account on the machine, so control over that service can mean full control of the machine itself. Question 7. What specifically makes an unquoted service path a security problem? Answer, Windows tries multiple shorter interpretations of an unquoted path that contains spaces. An attacker who can place a file at one of those earlier tried locations can get it executed with that service's privilege. Now, Active Directory. Question 8. Put these 4 Active Directory terms in order, from broadest to narrowest: organizational unit, forest, domain, object. Answer, forest, then domain, then organizational unit, then object. Question 9. What's the difference in job between Kerberos and NTLM versus LDAP within Active Directory? Answer, Kerberos and NTLM prove identity, that's authentication. LDAP is the protocol used to read, query, and write the directory's actual data once you're already talking to it. Question 10. Why is Active Directory often called the keys to the kingdom? Answer, because compromising AD, specifically gaining domain admin rights, typically grants control over every domain-joined machine on the network. And finally, PowerShell. Question 11. What's the single biggest structural difference between PowerShell's pipeline and Bash's pipeline? Answer, PowerShell passes structured objects through its pipeline. Bash passes plain text. Question 12. Is PowerShell's execution policy a real security boundary? Why, or why not? Answer, no. It's a safety rail against accidental script execution, and it's easily bypassed. It is not a defense against a determined attacker. One bonus question, tying everything together. Name one way any 2 of registry, services, Active Directory, and PowerShell directly connect to each other. Answer, any reasonable link counts here. A few examples. PowerShell can browse the registry as if it were a drive. The registry stores each service's startup configuration. Active Directory determines which HKCU profile loads at logon. However many of those 13 you got solidly right, on your own, without peeking, that's an honest read on what you actually know right now, versus what just looked familiar while you were reading. So here's your actual next step. Go do the Module 2 hands-on exercise now, while this is fresh. Get your Windows and Linux VMs installed if you haven't already, open Registry Editor and the Services console, and actually find 3 settings you recognize, not just 3 random entries you clicked on because they were there. Then hang on to this guide as a reference, because you're not done with these 4 topics, not even close. Registry, Services, Active Directory, and PowerShell will all reappear by name in Modules 5, 11, 12, 15, 17, 21, and 26. Get the foundations solid right here, and every one of those later modules gets easier. If this helped the module, click a subscribe helps this channel keep making the rest of the course. I'll see you in the next one.